Hi, this is Mohammad Quanit, and today we are going to learn about how we can develop Go applications on Docker. We will be looking some best practices of it, and we will be doing some. We will be reducing our file size. We will be looking at some uh, multi-stage pattern for reducing our Docker file for our Go applications. So in our scenario, I already created a Golang application with a simple web HTTP server, and what we need to do is what we will be doing is we will be creating a simple Docker application. We will be writing a simple Docker application. We will be looking at step on each of these steps, and then we will be refactoring our Docker application, and then we will at the end of at the last of it, we will be doing we will be applying multi-stage pattern with our Docker file. So this will be the scenario of my session, and here's who am I? I'm Mohammad Quanit. As I said, I'm working as a senior software engineer at Atom Point. So Atom Point is basically a company that incubates different startups from all around the world, local international. So it's more of a like startup incubation company. Apart from it, I'm also an AWS community builder at AWS, which is basically like the part of their community to showcase what you're providing for the AWS community. And apart from that, I am just a content writer on dev.to and educative as well. And below are my two social media handles where you can follow me. So without further delay, let's jump into the our code. So we will be doing all of these things live. So it will be a more of a like tutorial kind of thing. So if you have Docker installed on your machine, you can follow along, or watch it afterwards at your convenience. So without further delay, let's go to our code application. So I have already created a project in my VS Code. I'm using VS Code here. So I have already created multiple files here. The first one is the most important one, is the main.go file, where I have written a simple web server by using HTTP package. So what's basically happening here is that I have created two routes. One is for simple route and one is for /time route. And the simple route is basically just writing to the response writer like hello from /URL path. So if we go to this path, it's just return hello from / in browser. And for the second route, we are just returning the current time in specific format, and we just encoded it in a JSON format and returning it on the browser. So our server is running our localhost 8081. So if I start about my server right now, if I start my Golang server go. So as you see, the server is up and running, and we simply can go to directly go to the localhost. And if you can see my screen, you can see that hello from a /route, the current route has been printed on the browser. And if I go to the time route, then we will be seeing the current time, which is of my country, which is of my location right now in this specific format. So this is our simple Golang application, which we are going to Dockerize it. So before Dockerizing it, I have already created a file called Docker file, because when you have to create a Docker file for your application, there must have been a file called Docker file without any extension. And there's one tip I would like to share, is that whenever you're working with Docker file or Go applications, always use these Docker extensions. So it will help you into the auto completion part, and like it will help you debugging an auto completion part in your Docker file. As you can see that it's telling me that I have to provide some code here. And you can also use the Golang official extension as well for using in your Go projects for debugging purposes or for auto completion. So first of all, what we need to do is we have to provide a simple base image. If you have ever worked with Dockerfile, or so you know that we first have to provide the base image from where we have from which we have to create our image, right? So the first thing we will do here is we will provide Golang. So I'm using 1.18.1 version, so I'll just use it as similar version, and I'll be adding a Buster version. So why I'm using Buster, I will be sharing in a while. Like I'll be clarifying you in a while that why I use Buster, because we will be refactoring our Docker files. So there are some things you need to see when we are doing refactoring or when we are reducing our file, right? So the first step is to specify the base image for our Go application. All right. So the second step is we need to have a app directory in our image where we can hold our source code, right? So we simply can use the work directory. As you can see, there's already provided the auto completion part. That's because of like Docker extension is installed in my VS Code. So we can name our work directory is application. So this is our second step. Now the third step will be like we need to copy everything in the root directory from our app directory. So what we are going to do here is that we need to copy all of our source code into this app directory so that we can build our files from the image in our container. So what we can do here is we need to provide copy dot from current directory and dot from the app directory and dot from app directory. So this is how all of my files here in my in this folder can copied into app directory. Now the next step is to run go mod. Now we need to execute a script, run go mod download. Okay, so what this will do is first we need to have mode install dependencies. Okay, so when we copy all of our source files into our app directory, we need to install the dependencies which our application is dependent on. So if you have ever worked with like Node.js or JavaScript ecosystem, you know that you may have known that we need to install packages when we have a package or JSON file. So in Go's ecosystem is like a similar. When we are copying all of our files including go.mod into our app directory, we need to run this go mod download command so that all the dependencies will be installed in our image app directory. So this is another step to run the go mod download to install dependencies. Now the next step will be to build the app. So for this we will be using run go build -o for name, and then we will provide a go docker directory. So what this command will do is after installing all the dependencies, we need to build our source code and name it as go docker file. So if you have ever worked with Golang, so Go actually build in a small binary file size so that we can execute it directly or we can deploy it on different platforms, right? So here we are doing the same. We are just building our Go application with -o parameter so that we can provide a name of Go Docker so that we can we can execute our command, we can execute our application by using go docker command, right? And the last thing we need, and the second last thing, we need to provide docker about export. Like as I said, our application was set up on 8081. So here what we can do is we can provide 8080 ports. So but this time we don't want to provide, we want our application to run on 8080. We can do the same as the application server, but just for this session purposes, I am using a different port so that you can see the difference, that yes, application is running on different port and the Docker container is running on different port. And for the last part, we need to provide a CMD, and here we will write our go docker file. So in the line number 15, as I said, that after installing the dependencies, we need to build our go source code into an executable binary file which has a name of go docker. So this is what we are doing here, as we are using CMD command to execute the go docker file here. So this is our basic docker file. This is our basic docker file structure of Golang application, and here I am just killing the server which we have running before, and now we save the file. And now what I will be doing here that I need to build this docker file, right? We need to create a custom image, and how we can do this? We need to use docker build. If you see, okay, so I have installed an extension where it's just autocomplete the suggestions. So if you see this command, so rmt for tag. So basically what we are doing here is I can name go docker alpha. I have named my image as go docker, and I have already provided tag as alpha, and all of the current files along with my docker file, I need to build this docker file by using a dot pointer. So if I press enter, if you see, you can see here it already started to build our docker file. So basically these are steps from docker, and these steps are basically called layer in docker ecosystem. And you may be wondering that how is that Golang actually installed it in quickly, because I have already installed this Golang image in my cache. So whenever we next time try to install any image which we already installed before, so it comes from cache, right? So we already installed here, we already created a build here, image here, and now if I want to see my image, docker image ls, so here you can see I have already my docker image has been created with a tag alpha 3 seconds ago, and it's a size of 913 MB. Alright, so now you know that how we can create a simple docker file, basic docker file for our Go web application server. But there are some things which needs to be fixed here. Like there is still some catch which we can fix here. And what are those? So okay, so we see that we already provided our base image as Golang. We already provided our work directory app. Now, whenever you work with Go applications in a production environment, you just don't do this. It considered as a best practice. It's considered a bad practice, and it's because let's say if we have some changes in our file and we do this step, because Docker actually consider steps as layers. So whenever there is a change in any of our file, it will be like rebuild the image from that specific step. So let's say if we have some code related changes in our main.go file, so we don't need to run again go mod download because we didn't add any external dependencies or any additional dependencies. We only want to run this line when we actually install some dependency after creating the first set of first image of the build, right? So the best practice is what we can do. The best practice what we can do here is, first of all, we need to copy go.mod into our application, into our app directory, right? So first it will copy the go mod direct. So go mod, think of it like where you can monitor all of your dependencies or packages. It comes here in this file. Right now I am not using any package for this session, but whenever you installed a simple package by using goget, you actually see the list here, right below this line go version, right? So what we need to do is, first we need to copy our go mod, right, and then after we need to run go mod download. So let's say if we are doing some if we are adding some additional dependencies in our go project, so what it can do is that it does not run these. It does not run it whenever we create an image. Next time after doing some changes, it won't run these steps. It will directly see that yes, we have some changes and we had some change in our go.mod file. It will it will again copy that go mod file in the app directory, and then again it will run the go mod download as the change detects from this point of view. So all those above steps will be followed as usual, followed as well, because Docker is smart enough to detect changes from here. So when we add some new additional dependencies, so the Docker will run this command, which in which Go actually downloads the additional packages, and again then Go run. Then this command will also run as Go again create a new build with the additional dependencies with that Go Docker title, with that Go Docker file name. Again, we are exposing the 8000 port for our Docker container, and at the last we are executing our binary file by using the command /go docker. So whenever you are working with Go modules, make sure you are not copying just by doing dot dot, but you have to make sure that first you are tracking the changes in go.mod, because in production application, go mod usually changes a lot of time, and because because additionally dependencies are adding from time to time, and we need to create build along with every change, right? So this is the good way to track the changes and track the go mod changes, and again then these steps will run afterward. All right, so this is our Docker file ready. Now again we will again create a build for our Docker file by using the same command, docker build rmt docker alpha dot. Now we press enter, and this time it's okay. So you are seeing that Go no module dependencies to download is because I am not using any external dependency. So it just showing that hey, there will be no additional dependency to download for. So it just showed this message. Okay. And we have another issue here, no profiles in app. Okay. So first we need to okay, I actually forgot another step is when we actually download the Go mod download, when we actually run this command for downloading our dependencies, we need to add additional command as I really forgot to copy my Go files. So what I can do is I simply can provide main.go in our destination. I just forget this part of my like part of the Docker file. Copy source files. Okay, so I just forgot about this. And this is and the Docker file is telling me no Go files in app because we didn't copy any Go files in our app. So again, we need to build our image, and we try to again build our image. So as you can see, this time it does not show any error and it's successfully built and also successfully tagged as Go Docker Alpha. So yeah, this could happen in like live coding events. So if I saw my image again, if I saw my image list, you can see that again it's updated 20 seconds ago with the same 913 MB size, the alpha tag which we have provided. All right, so now you know how we can create a simple Go application in Docker file. Simple Go Docker file application. Now what we can do here is let's create a container. In fact, so Docker run and detach mode on port 8080, as we have provided, has exposed our Docker port 8080, and 8081 is our web server port, so we provided here as well. And I created with the name of Go Docker app, and this is our Go Docker. Now make sure, and this will be our Go image name. So what our basically Go image name was, so was Go Docker Alpha. I actually forgot what I named my image Docker run, and here we will provide Go Docker. So if we run this command, it will create a container on our newly created image, and it's already created in a detach mode. So if we go to Docker PS, you can see that it started on 8 seconds ago, and it's running on localhost 8080. So our container is up and running on this image file. So if I go to 8080/time, so we can see that this is our like container host, container IP with that specific route which we have served our current time zone. So now you can see how we can create a basic Go application with Docker. Now, as you see, if you have noticed before, let me show you Docker image ls. So if you see here, our image file called Go Docker has a size of 913 MB. And when you are using Go Docker files, when you are using Go applications and Dockerizing it and deploying it on some different stages, so it is considered to be a bad practice to provide that much of a big file to deployment, right? Ideally, it should be as small as possible. So this comes under the optimization part of the Docker. So what we can do here is that there's a concept in Docker called multi-stage pattern, where we can basically reduce our Docker file to make sure that it does not take as much as storage when we are deploying to any platform or any on-premise. Because obviously, if we have multiple services and we are creating different Docker files, then there will be that much of big files, and it takes a lot of storage, right? So we have to try to make it small as possible, and for that we are going to use multi-stage pattern in Docker. And how we can use it, let's get onto it. So what I can do is I just commenting out here all of the code, and I'm starting to write the new one, because it's a different way of doing multi-stage builds. So multi-stage builds not just only reduces your image file, but it can actually create different stages in your Docker file, so that one stage can be utilized into second stage, and second stage can be utilized into another stage, right? So the first step what we can do here is we need to simple provide our base image Golang 1.18.1 cluster. Now here we will be using as is for alias, where we can name it as builder. So for multi-staging builds, we need to create multiple stages of our Docker file. So I'm creating the first one right now. So the second part will be work directory. Work directory will be the same /app. The third step will be copy. We will first copy go.mod file into the destination, which is our app directory. Then we will run go mod and download to install our dependencies if we have any. And then we need to copy all.go file, usually in the destination. So usually what happens is that when you're working with a Golang application, you just don't have a simple main.go file. You actually have multiple files. For copying multiple files, multiple source files into the directory, we can use status.go app, so it can get all the Go files into the app directory. Now we need to run another command, which is adding some environment variables for Go. So enabled 0 COOS. We are providing these are basically the build configurations. When we do build of our Golang application, we will provide an additional configuration, and that is exactly we are providing, because you probably will have to see these kind of configuration in the Docker files for Go applications. So arch I just need, so go build, we will provide /o, and now I'm providing another directory in application, and we will be saving our build into that directory. So I'm using this go Docker multi-stage. So I have created, so think of it as like there's another directory in app called opt, and we will be naming it as go Docker multi-stage. image, that our multi-stage image will be named as Go Docker multi-stage, right? Now the second and final stage will be our first. We need to provide n from Alpine. It is so Alpine. So here in this case, Alpine is basically a Linux distro where we like really lightweight Linux distro where we can simply get our all this stuff into our Alpine, and whenever we create the image from multi-stage build, we will be a very much reduced file size, right? So for this, now the next step is we need to copy all the from stage. So here in our case, stage will be builder, and destination will be our opt Go Docker multi-stage, because we created another directory called opt in our app directory, and we want our application to be served from this directory, from opt directory called Go Docker multi-stage, and we need to provide another directory for it because Docker multi-stage. Okay, so this is not builder's build. Now the next step will be we need to again expose our port 8080 for our server, and at the last time we used CMD, but this time we will use entry point because we want to execute our file in a final stage build, so it's probably better to use entry point here. So we simply can run this thing. We simply can run this command because our Go Docker multi-stage image file will be in opt folder, and we just simply executing this command to start our container. Alright, so that's how our final build looks like. And if you are thinking like what are these for, so CGO enabled is basically for whenever if you have ever worked with Go applications with C libraries, then it's basically useful for wrapping or importing the C libraries into our Go applications. So these are it's basically useful for some of the operating systems so that it may build without any issues, as we are creating our build for Linux operating system, as you can see, right? So we just don't need to think more about it, as it's more of a Go thing, but just remember that we may need to use this environment variable when we are building our Go application. Alright, so we have already created our Docker file. We can save it now, and again we need to create and this time we will create another image by named Go Docker multi-stage. So build okay. So as you see, I have auto-completed in my terminal. So this time I'll be using command called docker build rm when we are starting our container, and this rm flag is basically useful when you want to start your container. Whenever you delete your image, container will also delete it. So we use that rm for this. T for the tagging part. So here we are providing our image name, and this time I'm not using alpha, I'm providing the targets beta, and we will be using all of the source file here which contains in this directory including the Docker file, so it will pick up from